Drone is in auto mode. It is covering its waypoints.
I am Priyanka Gupta. I have completed my second year from Computer Science Engineering at JUCRC Foundation, Jaipur. Our project mainly focuses on making a fully autonomous drone which could help in face recognition of a specific person from the crowd or at a particular location. Social and religious gatherings often result in missing of various people from their beloved families. Keeping this problem in mind, we have developed a fully autonomous drone which could further help us in recognizing of a specific person from the crowd or at a particular location. We have created an unmanned aerial vehicle UAV using the Ardupilot flight controller which can be controlled manually as well as it can fly autonomously. The Ardupilot flight controller is connected with a low-cost credit card-sized computer that is Raspberry Pi. We have used Raspberry Pi 3 Model B+. Raspberry Pi processes the files of the algorithm and captures the real-time video. Frames are generated from the video and are then compared with the pre-fed data, and the results are then processed accordingly. Haar-cascade uses the Ardupilot learning algorithm. It is a machine learning based approach which uses a lot of positive and negative images to train. Face detection uses classifiers to detect from image whether it is a face or not a face, that is 0 or 1. Classifiers have been trained to detect faces using thousands or millions of images in order to get more accuracy.
I am Bhavya Parikh from LNM IIT Jaipur. I have completed my second year in Electronics and Communication Engineering. We have initially used JK2.1.5 flight controller to test our understanding for the drone. It is the basic flight controller and it lacks the facilities like GPS and altitude hold, position hold. So for that, we needed an advanced version of flight controller. We then tried with NASA and multi-rotor light flight controller, but it was not an open source flight controller. That's why we were unable to utilize its software and programming for our work. Then we switched to the Ardupilot Mega, which is APM 2.8 flight controller, which is an open source flight controller based on the Arduino Mega board. This flight controller is programmed with the help of Mission Planner software, which is also an open source. In this software, we can input our waypoints or GPS coordinates and the drone will fly at those locations autonomously. Now I will demonstrate the working of Mission Planner software. This is our setup. We communicate with the drone wirelessly through the 3DR module. This is the screen of Mission Planner software. We connect with the drone with the help of MAVLink protocol. It is receiving various parameters from the drone. It is connected successfully. As you can see, there are various parameters like altitude, speed, yaw, pitch, etc. This is the screen, which is the view of the drone. If I will rotate or move the drone, then the screen will move and rotate accordingly. This is the flight plan screen. In this window, we add different waypoints with the help of our cursor. Waypoints are the GPS coordinates or locations where we have to send our drone. There are various functions which could be performed with the help of these waypoints, like loiter, loiter for unlimited time, return to launch, land, take off, rotate our servo motors, rotate our gimbal, etc. We can also add the time it should loiter. Once the flight plan is completed, we can write the waypoints in the Ardupilot. This is the complete setup of our drone. The Ardupilot is the main flight controller which controls and processes the commands and rotates the propellers accordingly. This is the Raspberry Pi camera which captures the video, and the Raspberry Pi processes the video.
Now, we will demonstrate the working of face recognition using Raspberry Pi camera from the drone's angle. We have also added the recognize function through speech whenever it recognizes the required person.
Found Priyanka. Found Priyanka. Found Priyanka. Found Bhavya. Found Bhavya.
This is the code through which the Raspberry Pi communicates with the Ardupilot Mega. We import various packages from DroneKit like Connect, Vehicle Mode, etc. We also import PiMavLink, which communicates through the telemetry port of the APM. There are various functions like basic pre-arm check, arming motors, waiting for arming, taking off, reaching a required altitude, and then land.